viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabat College, University of Delhi. So in our previous lecture we have seen that how can we create multiple threads along with one main thread. We have created three child threads. Now as these three child threads have been created and along with that we have one main thread also. One thread may might want to know that another thread has ended or not ended. So this is going to be today's topic of discussion, that how can one thread know when another thread has ended. And for example, in our synchronization thing, we have seen that one thread may be kind of waiting for other particular thread to get end in order to in order to proceed with its further processing. Now there are two ways to determine whether a particular thread has finished or not. So the two methods are, one is the method is alive and another method is the method join. So we will be looking into these two methods one at a time. So you can call this is alive method on a particular thread. Now this method as one can guess is defined by this thread class, and the general format of this method is final boolean is alive and parenthesis blank parenthesis. So that means it is not having any parameter in its general form at least. Then it is returning a value which is boolean. Obviously if it is alive, true or false, something of that sort, and this is a final method, that means it cannot be changed, and the keyword final we have also seen in our previous lectures in this series. So this is alive method will return true if the thread upon which it is being called is still running. So if the thread is alive will say you true, otherwise it will return false. And this is alive is kind of I can say occasionally useful. More commonly used method is the join method, and the general syntax of this join method says final void join, and this is kind of susceptible of throwing an exception. So we will say throws interrupted exception. So we have used this method join with the keyword throws, and the kind of significance of this keyword throws we have seen in our previous lecture. So again, both the methods are the final methods. Is alive method is returning a boolean value, while join method is returning nothing, that means the return type is void, and the parameters of both the methods is alive and join are nothing, that means blank parenthesis is there as far as parameters are concerned. So this method join I am talking about will wait until the thread on which it is being called terminates. So that is why its names comes from the concept of calling the thread waiting until the specified thread joins it. And additional forms of join, as I have told you that whatever form I have just shown is actually a general form. So additional forms of joins will allow a programmer to specify some maximum amount of time that the thread can wait, that a programmer can wait for the specified thread to terminate. As I have told you that the method will wait until the thread on which it is being called terminates. So we can have a maximum kind of amount of time for which it should wait. So we are going to use this join in our program also, and let us begin, let us see how this whole program goes on. So we have a class new thread, and this structure by this time this programming structure is kind of quite familiar. So I'll explain wherever it is kind of a new concept getting introduced inside the program. Otherwise I'll just quickly kind of rush through this, because we have seen this 3-4 times. So class new thread, it is implementing runnable, because I have told you that this is the simplest way to create a thread, and one should not extend the one should not use the concept of inheritance unless an added functionality is going to be there. So we have a string name, the object t, and within the new thread we have created thread. So this is the procedure of creating the thread and starting the thread. The constructor of this class new thread will being called upon inside our subsequent methods. Entry point for the thread is obviously the run method, and within this run method, that I can say a familiar structure, which is I is equals to 5 to 0, the reverse counter, making the thread sleep for 1000 milliseconds. And now we have catch interrupted exception E with corresponding to try, we have a catch block also, and we have seen name exiting. Then how are we going to use is alive, how are we going to use join? The class new thread till this point in this program is something which is very familiar to us, because we have already seen that this particular class and kind of that run method and the constructor and their functionalities in our previous examples also. So here we have the main method inside the class demo join, which is actually creating 3 new threads by the name or by the tag, by the label I can say, which is 1, 2, 3, and that this is also we have done in our previous lectures. The essential thing is there that these references are now being stored inside these reference variables, which are OB1, OB2 and OB3 respectively for these new threads 1, 2 and 3. Now we are going to print if thread 1 is alive, then we are calling this is alive on your OB1. So OB1 dot t dot is alive. Then we have thread 2 OB2 dot t dot is alive. Then for the third thread, which is the thread 3, if it is alive it will print true. For that also we have called OB3 dot t dot is alive. So that means we have created 3 different threads, and we are now running this is alive method of your thread class on these reference variables. Now this was is alive. So if it is kind of allowed, if the thread is alive, then we may use our join method also, which is waiting for the threads to finish. So we have used our try catch, because I have told you that this join is going to throw an interrupted exception. So that has to be kind of enclosed inside your try catch block. So the try thing says system.out.println, just a simple message as saying waiting for threads to finish. Then we have for the first reference variable OB1, it is OB1 dot t dot join. Then for the second one OB2 dot t dot join and OB3 dot t dot join, and corresponding to the try block we have catch, which is interrupted exception E, and it is printing main thread interrupted, because this whole procedure, this whole processing is actually going inside the your main thread. And then we have if we are going to run this program, then let us see how it is going to work. So first of all, this these new threads are being created 1, 2 and 3. Now what is the information which is being which is being written inside this thread and the square bracket? So the name of the thread, then 5 is actually the priority number, and which is the parent thread. So parent thread is the main thread through which these threads have been kind of we can say created or produced. So we have this 1, then 5, then main thread. And before finishing off the program, we have used our is-alive method twice within this program. One is we have created the threads called is-alive for all the 3 threads. Then we waited them for to finish, and then we have used join for that particular purpose. And then again to verify, we have we have kind of checked and printed that whether these threads are alive. So basically what I am trying to say here is, when we are going to run this program, we will be having the status of the status whether these threads are alive, yes or no, before calling the join method as well as also after calling the join method. So output will be something of this sort. This output is going to be continued for 2-3 more slides. So first of all, these 3 threads are being created as the child threads of the main, named as 1, 2, 3. The priority level is normal priority, which is 5. Then we have thread 1 is alive. This is the this is the output of calling is alive before joining. So thread 1 is alive, true, thread 2 is alive, true, and so is thread 3. Now after this we have written join method. Now this is saying waiting for threads to finish, and these threads will start their working starting from 5 to 1. They'll kind of print, and here you can see that there is no particular sequence. So for example, with 1, 2 and 3, we 5 is being printed, then we have 1 for which 4 is being printed, then for 3 3 is being printed. So it is actually in a kind of we can say haphazard or in a zigzag manner. There is no particular sequence. And now how these threads will exit, that is for this particular run of this program, 2 exits first. So 2 is exiting will be printed, then 3 is exiting will be printed, and 1 is exiting is printed. So that means this is also not in the sequence. That is why I have given you this disclaimer so many times that the output of the program will specifically depend on the execution environment. Even if you are running this particular program on the same machine, maybe after some times or immediately after this may not kind of give you the same output. But now all these threads have exit, and join was waiting for them to exit. Now if we are going to call again or look for the status check again, that is thread 1 is alive or thread 2 is alive or thread 3 is alive, it is going to give us false, because all these 3 threads have been already exited. And then finally the main thread exit. So in this complete program, let me give you a quick kind of complete flow that what has happened. We have created 3 threads and we have checked the status of these 3 threads using is alive. Then after we have tried we have called join method on these 3 threads, and join is the method which will kind of which will wait for their termination after printing the value of their counter 5 times. All the threads, all these 3 threads exit, and then after this termination, we have again checked that whether these threads are alive. So earlier it was true, threads were alive, and now after exiting, obviously your is alive is going to give you a false result. So thread 1 is alive, no, false, so is thread 2 and thread 3, and finally the main thread is exiting. So this is what is actually, you know, kind of we can say utilization of your is alive and join thing. So here till this point what we have seen, creation of multiple threads from our main thread, and kind of I can say one in a one way it was kind of communication between the threads using your is alive, or synchronization of threads can also be taken in this way, that we are using is alive and we are using our join method. Now you must have noticed that whenever a thread is being created and whenever we are going to print the information of that thread, three things are there. One is the name or the label or tag of that particular thread. Next is the name of the parent thread, which is essentially main here for all of our programs which we did till now in this topic of multi-threading. And in between these two informations, one which is being displayed is actually a number. Now I am going to talk about that number. So that number is related to priority. So what actually a priority is? So priority is something, or it is actually a tool, I can say, which is going to be used by thread scheduler to decide that when the thread should be allowed to run. Thread, as I have told you, kind of these are different processes which are going on inside the system. So theoretically I can say over a given period of time, higher priority threads get more CPU time than lower priority threads. So that's I can say it's a general, or it's a typically theoretical concept, but in practice it is not only the kind of the priority, or it is not only that number. So priority is in the form of a number, in the form of an integer. So it is not only that integer, or it is not only that higher priority thread is going to more CPU time. In practice it depends on several other factors besides the priority. Also a higher priority thread can also preempt a lower priority one, and this concept we have also seen in our operating system courses, that a higher priority process can also preempt a lower priority one, which essentially means that when a lower priority thread is running and a higher priority thread either resumes maybe from from sleeping or from waiting from an input output device, it will preempt the lower priority thread, and now onwards, or after this particular point, the higher priority thread is going to run. Now priority, as I told you, that this is going to be a number. Typically this number is in between 1 and 10, and 1 is having a different meaning, and the higher numbers are having the different meaning. I am coming to that. And now how are we going to set the priority of the thread? So we have a very simple method in order to set the priority, that is set priority method, which is member of yes, you guessed right, it is the thread class. And how are we going to use this? The general form is it is not going to return anything, so that is why the return type is void set priority. What priority I am going to set? Obviously within a specified level, that priority number, that integer should go on as parameter, and this is a final method. So final void set priority int level, and here level, as I told you, specifies the new priority setting for the calling thread. Now what could be the value of this level? The value of level must be within the range min priority and max priority. So min priority and max priority, this is min underscore priority and max underscore priority are two actually I can say constants, and typically these values are 1 and 10 respectively. So, that means 1 is for min priority, minimum priority, and 10 is there for the maximum priority. So, we can set any level of the thread which is calling this set priority method starting from 1 to 10, both inclusive. So, if we want to have the thread to be on lower priority, we will assign the lesser number, or if we want to have it on the max more priority, if we want to assign more priority to that thread, we will give a higher number close to 10 or maybe 10 itself, which is the maximum priority. Now the question comes up, what is the default priority which is kind of there. So, default priority is actually being denoted by a constant which is norm underscore which is named as norm underscore priority, and which is typically 5, and that is the number which is being displayed when your thread is being created. So, one method is to set priority and the level I have given, I have explained, and another situation is, in order to obtain the current priority, we have one method which is the get priority method. This is of the thread class, and the general format goes like final int get priority. So, get priority will be called on a particular thread. So, this get priority will tell you or will return the integer number corresponding to the priority of the thread on which it is being called. And again this is also kind of we can say final method, so you can't change it. Now with this setting of priority and looking into the examples of multi-threading which are being used using is, alive and join, we also look into the concept of inter-thread communication. Now one idea behind using the concept of multi-threading is to have this multi-processing implemented in one way. Another benefit of this threading process, another benefit of this multi-threading is they do away with polling. Now let us try to understand what is polling and how this is actually an undesirable situation, and threads help us to get away from this polling thing. So, polling is actually implemented by a loop which is going to use which is used to check some condition repeatedly. One particular condition when true, then appropriate action is taken, and that loop keeps on going on and going on until that condition has become true. So, this is actually kind of, I can say, it is a wastage of the CPU time. Now, in order to understand this concept of polling, let us look into a classical queuing problem, which is the producer consumer problem. Now, this producer consumer problem is something which is in the classical literatures of computer science. Here one thread is producing some data and another thread is consuming that data. Now, for example, that the producer has to wait until the consumer has finished before it generates more data. So, that means producer is actually dependent upon the consumer. If consumer has finished, then only producer will kind of generate or produce more data. And now in a polling system of in such a scenario, it is going to waste many CPU cycle, because the consumer may waste or would waste many CPU cycles while it waited for the producer to produce, or vice versa it could happen. Once the producer was finished, it would start polling, wasting more CPU cycles waiting for the consumer to finish. So, this is kind of an I can say one is dependent or one is looking to another in order to start or in order to resume its own processing. So, this is what a polling system is. Now, in order, and this is actually an undesirable situation, because it is wasting the whole kind of wasting so many CPU cycles, which is a very important resource. Now, in order to avoid polling, Java includes an inter-process communication mechanism, which is with the help of three methods. One is wait, another one is notify, and third one is notify all. These methods are implemented as final methods in the object, so all the classes will have them, and all these three methods can only be called from within a synchronized context only. Without the synchronization context, we cannot call them, because they are helping in the inter-process communication. Now, although we look as a very we look into the polling as a very conceptually advanced form, but the rules for using these methods are actually quite simple, and Java as the language has given kind of very simple signature and specifications to these methods. So, the wait method tells the calling thread to give up the monitor and to and go to sleep until some other thread enters the same monitor, and for that it is going to call either notify or notify all. The notify method wakes up a thread that called wait on some object. Similarly, notify all wakes up all the threads that called wait on the same object, and in case of multiple threads getting waked up, one of these threads will be granted access. So, this wait, notify and notify all are the three methods which are going to be used for inter-process communication in the scenario of synchronization context, we can say. So, here in this lecture what we have seen is how we are going to use is alive and join in order to check up the status of whether a particular thread is live or not. Then we have seen some concepts related to multi-threaded programming, and then after that we have seen in a brief manner, yes, we have seen three methods which are wait, notify and notify all. These are being used in the inter-process communication, and here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.